Hi guys, my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing matrix algebra. Particularly under matrix algebra, I'll be looking at finding determinant of a squared matrix. Like we all know that it's easier to find determinants of squared matrix, but it had been, I want to say had been because there have been new methods to find the determinants of unsquared matrix. So in the past, it was like impossible to find determinants of unsquared matrix, that is determinants of rectangular forms of matrices like 3x4 matrix, 2x3 matrix, and so forth. But now, yes, it's possible to find determinant of unsquared matrix. So if you check my other videos, you will see how we find determinants of unsquared matrix. But in this problem, we want to look at how we can easily find determinants of squared matrices. So we said given matrix A, matrix B, matrix C, matrix D, and matrix J. So we know that from the definitions of matrices, matrices are named using both face capital letters. So because we do not have a kind of bold face letters here, so we have strokes under these letters to indicate that these are matrices, and these are also standard ways that matrices are named. If you check some softwares, you will notice that the names of the matrices will come out of the softwares when they are printed out with these symbols under them. So we have 5 matrices, and there's a problem that has been given to us to find that somebody may say the absolute value of matrix B plus matrix C. So this symbol that is, is appearing like an absolute value symbol, it is what we refer to as the determinant of a matrix. So the determinant of a matrix, you can see this represents the determinant of matrix A, or you can see DET of matrix E. So this represents the determinant of matrix A and determinant of matrix A. So let's look at the first problem. And after this problem, we're going to solve several other problems. That's why we have like 5 different matrices on the board. So the problem says, what is the determinant of matrix B plus matrix C? So before doing that, the first thing we need to do is to work with in. So we first need to find the sum of these 2 matrices, thereby forming a single matrix. And from that single matrix, now we can find the determinant of that single matrix. So we first find matrix B plus matrix C. And we know that from the introduction of matrices, matrices are added when both their rows and columns are the same. So 2 matrices are only added when their rows and columns are the same. So let's look at the 2 matrices. So we have matrix B, which is this matrix, 6 minus 2, 5, 5, 7, 4, minus 2, 3, and 1. Plus matrix C. Matrix C is 2 minus 2, 9, 0, 3, 1, 1, minus 7, and 5. So, and what do we refer to as rows and columns? So these are what we call the rows. 1, 2, and 3 are our rows, and 1, 2, and 3 are the columns. So these are the columns and these are the rows. So here we have the dimension of this matrix to be 3, by 3. This is the dimension. And on this side, the dimension is also the same as the previous one. So we have 1, 2, 3 rows, and also 1, 2, 3 columns. So here we have a 3 by 3 matrix. So because the rows and columns are the same, we can apply matrix addition. We can also apply matrix subtraction. If the columns and the rows of the two matrices are not the same, you cannot apply matrix addition or subtraction, because you're going to operate with item by item, element by element in the same positions. So let's look at now. Let's add them. So we have 6 plus 2, right? It's like saying 6 plus 2. Then we go to the next position, minus 2 plus. So it's minus 2 plus minus 2. Then here we have 5 plus 9. So we've just added all of the, let's say with the 2 rows, we've added them. Move to the next row. We have 5 plus 0. 5 plus 0. Then we have 7 plus 3. 7 plus 3. Then we have 4 plus 1. We have 4 plus 1. And here we do have minus 2. Minus 2 plus 1. Positive 3 plus negative 7 plus negative 7. Positive 1 plus positive 1 plus 5. Now, so we can simplify that, and then we will have matrix B plus matrix C to be equal to. So we have 6 plus 2 give us 8. Now the signs here are different. So when you are adding two numbers, the signs are different. Let's say the signs are the same, you add and take one of the signs. So minus 2 and minus 2 is minus 4. And then this one, the signs are also the same. Positive 5, positive 9 is positive 14. 5 plus 0 is 5. 7 plus 3 is 10. And 4 plus 1 is 5 as well. Minus 2 and positive 1. So the signs are different. We subtract the smallest number from the biggest number. So we subtract 1 from 2 and end up within the sign of, ends up with the sign of the biggest number, which is minus 1. So we have positive 3 plus minus 7. Again, we subtract. So we're left with minus 4. Here we have 1 plus 5 is 6. Now we've just carried on the operation of this expression. So now I can erase this one. And now we know that when matrix A and matrix B and C are added, this is the result. So I'm going to use this result now to determine the determinant of matrix B plus matrix C. So I'm going to use two methods, and the two of them will give you the same result. So we know that this thing now has turned into the sum of the two matrices. So this now will be B plus C. So we're going to use the two methods. So let's see how it works. Now, in the first method, we want to hold on to these. Now, mind you, the signs of these things, you have positive, negative, positive, negative, positive, negative, positive, negative, positive, and so forth. Right? Thank you. So let's pay attention to this. So now we hold on to this. It's 8. So remember, we had a positive sign here, so it means that this is positive. And then we cross out the rows. Let me get a red marker. So we cross out the rows. and the column. So what are we left with? We are left with 10, 5, minus 4, and 6. And remember, I told you this is positive, this is negative, this is positive, and so forth. So this one is also negative, positive, negative. So the next error you will have minus, this minus. Then now you can put this minus 4 outside. So we now erase this one. So we can cycle this minus 4. And then we cross out the columns of minus 4 and the row of minus 4. So what will be left with now will just be 5 minus 1, 5, and 6. Plus, remember minus plus, plus minus plus. Plus the last one, 14. We write 14. Then we cross out the rows and the column. So it means the center will remains. So you just have the elements left to be 5, 10, minus 1, and minus 4. So we're done now. We're done. So I can just erase these guys. Just erase them so that in the next problem we can be able to see them. Okay, this is negative. Okay, so we can now carry on our operation. So this is 8. So we have here 8. Then we put this in kind of parentheses or bracket. So we have 10 times, so it's like we cross multiplying. So 10 times 6. So 10 times 6. So we got 10 times 6 minus, remember it's positive, it's negative, minus 5 times 4. So it's 5 times minus 4. Then we move to the next one. Minus 4, or minus times minus is positive. So this gives us positive 4. Then we multiply 5 times 6. So it's 5 times 6 minus, then 5 times minus 1. So it's 5 times minus 1. Plus the last expression, this one, 14. So we have 5 times, so it's 5 times minus 4, and then minus 10 times minus 1. So there is not metric symbol any longer. This is just bracket, because bracket encloses parentheses. So that's the reason why I'm using that. So we can further simplify. So we have 8. 10 times this is 60 minus, this is negative times negative is positive 20, plus 4 times, now 5 times 6, and then so 5 times 5 is 25. That is 34, right? Not 34, but it's 5 times 6. It's not. So it's 30. What is it? 5 times 6. 5 times 5 is 25. 5 times 6 is 30. See how? So gracious God. So it's minus 1 times minus 5 is positive. It's positive 5. And then plus 14 times. So 5 times 4 is minus 20. And then negative times negative is positive. There is 10. So right in here we have 20 times 20 plus this one give us this 8 times 80 plus 14 So this is 35 plus 14, and then in there is minus 10. So if we do our multiplication, 14 times 35, so you have 14 times 35, so it gave us 490. So the first one, 8 times 8 is 64, so this is 64, 0 plus 490, and then plus, okay, so it's 14 twice. No, the first one is 4, right? This is 4, this one is 4. So it's 30 times 30 plus 5, 35, then 35 times 4. Okay, so this is now 490 is the next. So it's 4 times 5 is 20, and then 4 times 3, 12, 13, 14. So it's 14, 140, and then this is 14 times 10 now is minus 140. So if we add these three, you got 140 minus 140. So our answer there is just 640. So the determinant is 640. So let's put our answer up here. So the determinant is 640. Now let's use a shortcut method. I think that method we used was a bit long. So let's now apply a kind of shortcut method. So we have this expression to be B plus C. So this now is equal to, now what we can first do is minus 4, 10, minus 4. Okay, so this is not the determinant yet. This is 14, this is 5, this is 6. So what we can do now is the first two columns, this column and this column, we can insert them outside so that we complete a kind of multiplication. Look at, we can multiply all of these. We can, so we want to complete it. So we take the first column is 8, is 5, is minus 1. So that is completed. And if you carry this again, so you need the second column, minus 4, 10, and minus 4. So we carefully see that now. We just carry on our multiplication. So it is all of these expressions. So multiplying all of them. So you have, remember all of these are all positive, and the ones going upward, they are the negative. So we have the determinant of matrix B plus matrix C now to just be 8 times 10 times 6 plus minus 4 times 5 times minus 1 plus 14 times 5 times minus 4. That's the first one. Then we want to say minus. So we want to say minus the upper portion. So we take this upper portion. So it's minus 1 times 10 times 14. Take the next portion. Plus minus 4 times 5 times 8. We'll take the last portion. Plus 6 times 5 times minus 4. So this whole thing, we put it in bracket and we sum them up. So let's get our calculator. So in the first area, you have 8 times 10 is 80. So it's 80 times 6 gives us 480. We have a plus sign here, but minus times minus is positive. 4 times 5 is 20, so it's 20. Then this one, we have 14. Now positive times negative, it gives us negative. So we're just going to multiply the 14 times 5 times 4. So it's 280. It's already negative because we already dealt with the signs. Minus, so we still maintain this one in the parentheses. So that minus, now this is minus 1 times 10 is minus 10 times 14 is minus 140. So this one is 8 times 5. 8 times 5 is 20. So it's 20 times 8. And you know that it's like 160. So it's like 160. So it's minus 160. Then negative times is positive, it's negative. So it's 4 times 5, 20. And then 20 times 6 is 120. So we add 480 plus 20 is 500. So 500 now minus 280. It gives us 220. Then we have a minus sign here. So the signs all here are the same, so we can add all of them. 140 plus 160 plus 120. So it will give us 420. So we take one of the negative signs. 420. Now negative times negative is positive. So it's 220 plus 420. So if we add the two of them, 0 and 0 give us 0. 2 plus 2 give us 4. And then 2 plus 4 give us 6. So you see, we have the determinant in the second method as the same as the determinant in the first method. So you can use either this method, which is almost like a kind of shortcut method, or you can use the previous method we just used in the problem. So thanks ever so much for watching. See you in our next video.